Warning: tube amplifiers have lethal voltages inside them. Please do not attempt to build, test, or repair these without understanding and following all safety protocols. Hey y'all! Well, today we're going to talk about something you just don't see anybody talking about in forums or in videos or anything about tube gear is thermal design. And a lot of people, I think, don't even consider that that's an issue. And you may be asking, why should I be concerned about this? I mean, it's just, some of these parts are rated for high temperature. We're good to go, right? Well, you take a 105 Celsius capacitor that's rated for 5,000 hours of use, which is a pretty normal kind of a rating. And you think, oh, well, it can handle 105 degrees Celsius. Well, yeah, it can handle it and not blow up for 5,000 hours. But that happens pretty quick. I mean, not instantly, but in a fairly short period of time, you're going to have 5,000 hours, especially if you're like me and being a dummy and sometimes forget to turn an amp off before you go to bed and sit there running all night. It doesn't take a long time to rack up a bunch of hours. And for every 10 degrees C that you lower the temperature, it doubles its life. So if you pull it down to 95 degrees Celsius, you're now at 10,000 hours. You drop it to 85, you're at 20,000, etc. And a lot of the caps used in this gear are only rated at 85 degrees C, and cathode resistors can exceed that fairly easily. And especially resistors that are put in to balance the heater voltages, or if you're trying to drop the B+, or you're using like an RC filter in the power supply, those things can get really hot. And our test subject is this pair of 2A3 monoblocks that someone sent me, and there were a couple of goals. One of them wasn't related to the thermals. That was something that I mentioned to the owner when I looked at them. His complaint was that he bought these because he wanted to hear some tube sound, or to hear that warm kind of tube lushness that we all buy tube amps for. And he said these things sound just like low-powered solid-state amplifiers. And when I ran the audio analyzer suite on them, yeah, they were super low distortion, and I can understand why he would say that. But this video, we're going to focus on the thermals. When I opened up the box or unboxed these things, first thing I noticed was this is a totally sealed case, and you may see these little screens. These are like the modded ones. I'm recording this after I did the mods, but anyway, they were just a sealed box. There was no holes in them anywhere. There were no holes around the tube sockets. There were no holes anywhere. It was just a sealed up box. And then inside the chassis was the cathode resistor for the 2A3, and there was a pair of power resistors off the rectifier tube to drop the B+ voltage, which these things are already running super hot. I can see why they did that. They had to. It would have killed the tubes. But anyway, and you'll see in the video the measurements that I did that weren't worst case because I didn't have the bottom sealed up with the cover, and there was stuff inside this thing that was over 95 degrees Celsius after running for 30 minutes. And I'm sure after several hours, it probably would have been over 100 degrees Celsius, which is over 200 degrees Fahrenheit. And that's just going to fry all the capacitors inside it. And so I'm going to show y'all what I did to, I believe, at least help the thermal design of this to make the capacitors live. So let's get busy fixing this amp. So let's take a look at what's going on inside this little amp. mainly at first from the thermal perspective. We've got a couple of big heat producers inside this amp, and obviously the transformers do put off a little bit of heat. We've got power transformer over here. We got a filament transformer over here. But the main heat producers are these big power resistors. We got a pair of 250 ohm power resistors coming off the plate of the rectifier tube over here to the B plus terminal on this tag strip. And these things are running pretty hot. I ran the amp with the bottom cover off of it, but with the bottom facing down to the table to simulate what it would be like with the cover on it. And it still was getting a little bit of air coming in from the sides, but it was pretty much, sealed off like it would be with the cover on it. Ran it for about 30 minutes, which really isn't an extended period of time, but is long enough for the stuff to get heated up. And I came in with my little thermal heat gun, or my infrared heat gun, and this little bundle of wires here underneath these or above these resistors, 90 degrees Celsius or 195 degrees. That's not good. The other thing that's putting off a lot of heat is this cathode resistor for the output tube, and you note it is physically touching this bypass cap right here, which that's just not a good idea. And measuring this, I've got 80 degrees Celsius at some points along this resistor, which is 175 degrees Fahrenheit. And like over here when I said 90 degrees Celsius, that's 195 degrees Fahrenheit for you folks here in the US. So definitely getting way too hot. And then here's the lower cover. You can see just a solid cover with no ventilation whatsoever. And then when you look at the top of the amp, it's all sealed up too. And the other place that heat comes into the underside of the amp is, some people don't realize that some of the heat from the tubes themselves comes through the pins and into these sockets that the tubes plug into. So we've got heat there. So what are we going to do? First thing I'm going to do is this resistor absolutely needs to be moved. It should not be in contact with this. And I know this looks neat and this gives it that turret board look that some people really like, but this is a really bad idea to have this resistor touching up against this one. Now, one thing we could do if you wanted to kind of keep this look would be to use some of the 3D space in the amp. And let me see if I can twist this thing to kind of show you what we could do. We could raise this up. Have this wire come up and then have the resistor sitting up higher like this, but you still got the heat just rising up across these capacitors. I suppose you could move this capacitor, the same thing, move it up and get it away from this resistor, but that's still not ideal, I don't feel like. So another option is to go with these type of chassis mount, or whatever you want to call these things, where they put a thermal pad or some thermal grease and bolt it to the chassis so that it transfers the heat to the chassis. And I talked about this with the owner. One thing we could do is put it like back here, and that gets it away from the capacitors and transfers the heat to the chassis itself on the back of the amp. But the other option, and I know some of you guys are going to eye roll about this, is to mount it here on the back of the amp externally like this, and put a couple grommets, put like one here and here, run the wires through the inside of the amp. And if you're concerned about this, there's about 40 volts on one side of this, which to me, it might give you a little tingle, but I don't consider that like deadly voltage. If you're really concerned about that, you could cover this with some of that liquid electrical tape and, seal it off so you can't touch it possibly. The advantage, though, to having this mounted externally is it gives you a point to measure the voltage drop across this resistor to measure the current running through the tube, or what the bias is doing. And it also helps you measure the performance of the tube and how much life it has left. In case the tube starts dying, you'll see this voltage change. And he liked this idea, and so I'm going to mount it externally like this. It will transfer some of the heat to the chassis here, but I feel like the majority of the heat will just radiate to the air outside of the chassis. We just get that heat source out of the inside of the amp. And I know some people really don't like that I do that on some of my amps, but almost all my personal amps, I've got external resistors like that, just to keep the heat from outside of the amp. So we still got the heat from these two guys right here. So yeah, I get what they're doing with these resistors. I think they're trying to drop some of the B plus voltage and also pull the current from both sides of the plate of this direct heated rectifier tube that they're using. A better solution to me would be to use a center tap transformer, but that's not what we're working with. And so, yeah, we have to just live with these things being inside the amp. So what I'm planning on doing is separating this wire bundle and moving one half of them over here on this side of the resistor pack, and then pull this green wire over here on this side. And then right here in the center, I'm going to drill a 1-inch hole and add a screen vent right there on the top of the amp, just above these resistors, to let the heat rise up out of the amplifier and not get trapped, and have that 90 degrees Celsius that we measured here going out the top of the amp. So to make this function, we're going to need holes in the bottom of the amp so it's not a sealed box. And I'm thinking about putting the holes like over this area over here, so that the convection of air will come in here, go across this area of the amp, and then out the top. And that'll help keep this from being like a dead air space inside the amp. Because if we put the ventilation holes right here in the bottom of the chassis, it's just going to go straight through, and this area over here will be stagnant air. Or if we put them over here, the air will flow like across the amp and out the top. So that's the main thing we're going to be doing for the thermals. Oh, and I said this, I was talking about this. This is a choke. This isn't the transformer. The power transformer's on the top. But this is a power transformer. And this choke will get a little warm too. But probably not anything like what these resistors are doing. So the other thing that seems kind of weird about this design is over here we've got the grid leak resistor for the 2A3 tube. And they used a 47K grid leak resistor, which is a super low value. They're using the values stated for a fixed bias design, and this is not a fixed bias amp. And so we can use a much higher value resistor, which then allows us to use a lower value coupling cap. This has a 1 UF coupling cap, which in my opinion really isn't a big enough cap to be using with that size grid leak resistor anyway. And the other thing that seems kind of strange is they used, looks like really high quality, filtering caps for the power supply and stuff like that, but then they used like the bottom tier Mundorf coupling cap between the 6S7 and the 2A3. So I'm going to change this from a 47K to a 330K, and then install one of these aluminum foil 0.22 UF coupling caps between the driver stage and the output tube. And we'll be doing some testing to see what potentially that does to the distortion profile. One of the things that the owner that sent me this complained about, and some of you might laugh, he was saying that it sounds too clean, and he was expecting it to have some tube sound, and he says it sounds just like one of his solid state amps. And I've been reading some that with this type of driver stage, the grid leak resistor, which is what this stage is going to be driving, is this resistor. That's the load on it. Changing that can change the distortion profile of the amplifier. So we've got two monoblocks here, so we're going to do the mods to this one, the thermal mods, and then change this resistor and this cap. And then the final thing that I want to change is it's got this really old school looking capacitor across the power switch, which is there to eliminate any sort of pop that you might get from turning the amp on and off. And so I'm going to install one of these modern XY safety caps across that switch just to modernize that and make it more safe. The other thing that's kind of strange, and I guess I'm just going to leave this alone, it's got this weird mute switch. Hopefully you can read upside down. And yeah, I'm not really sure what the function of that would be. And it does create having this wire running across the amp like this, which seems a little strange, but you know, I guess I could bypass that, but maybe just leave that alone. That's kind of one of the features that this guy added to this amp that built this. And so, anyway, those are the changes that I'm going to make to this thing. So let me get this stuff all done, and then we'll come back and show you what these mods look like as far as the thermal improvements. And then we'll hook it up to the audio analyzer suite and see what changing this resistor cap combination does to both the distortion profile and the frequency response curve, and see if it has any impact or no impact. Who knows? It may do nothing. It might make a nice improvement. We'll have to see. And that's part of the fun of working on this stuff, is trying things and learning from what these changes do. So let me get busy doing this stuff, and we'll come back and I'll show you what this looks like. Okay, so let's review what we've done here. We removed this resistor that was the cathode of the output tube from this point right here. And you can see the two wires coming up here, and it's now mounted back here on the back of the amplifier. And like I said, if you're concerned that somebody's fingers might get into this, you can get some of this liquid electrical tape. I use this Permatex stuff here. Had really good luck with it. You can put some of that over these terminals and make sure that nobody could touch them. But the owner of this amp asked me to leave them exposed, which is what I would do, so that you can externally check the bias of the output tube. So we got that done. Up here on the front, we got our 0.22 UF aluminum wool Mundorf cap. Put a 330K grid leak resistor on the output tube, and that should improve the sonic performance. Then finally we put a little screen here in the top of the chassis above these two hot resistors coming off the rectifier tube, so the heat from them can vent out the top of the amp. And then we move these wires to the left and the right to get them away from these resistors so the heat isn't cooking those wires. And then the last step was I drilled some holes here in the back of the amp. You can see right here in this back corner. and that'll let the air come in that then flows out the top through this screen. And then the air can kind of go across this area here as it goes across these resistors and out the top. And that should help keep the inside of the amp cooler, a lot cooler. Oh, and then you can see here I put a XY safety cap across the switch, and then we remove this really old looking cap, which I don't know, I just didn't trust it being across a live switch. And I know these are safe to use in that position. And then we'll show you what the top of the amp looks like. And here's our little screen here. Put it between the rectifier tube and the 6S and 7, right directly over those resistors. And I think that looks nice. I guess if you really wanted to, you could put another one over here. But I think it was nice to have that one over there on that side and have the vent holes in the bottom and the air going diagonally across the amp. So there we go. And here's the front. I'll show you a couple of things that I would have done a little differently if I had been building this amp, but I don't feel like they're a deal breaker or anything that is going to cause any problems. And these amps are quiet. I didn't hear any hum, so I'm just going to leave it like they are. I don't quite understand why we put the power switch over here on this side and then run the AC switch wiring all the way across the amp when we've got a switch right here and a rectifier tube right here with AC. It would have been a better idea to me to put this wiring to this switch here and keep all the AC over on this side. And then if we'd made this the mute switch, the wiring over to it would have been much shorter. So I'm not sure if they had these front panels already printed up and they just didn't want to have to reverse them, and they put the switches like that for that reason. And the other thing that seems kind of odd is this 5-volt wiring for the rectifier tube. Why you would run it like down and around and up here when there's just a little short path right there. I can understand this wiring, but honestly I probably would have, instead of running it around this way, I would have run it around this side away from all this signal wiring and kept the AC like as far over this way as I could. And then the final thing was, I don't really understand why they ran this wiring here, the 2.5 volt that's going to the heater on the 2A3, why it was run back and around and up here right next to the input signal wire instead of just running it from here to there and just keeping it totally away from this. Yeah. Doesn't make a lot of sense. And I might even, kind of do something like this and put a wire tie on there. Kind of tie that up away from this signal wire. Doesn't that make a little more sense to you? So that's a simple thing I can do, is just cut these wire ties and kind of wrap that guy around like that, double it back on itself, and get it away from the signal wire. Even though this is shielded wire, you still should try to keep AC, especially high current AC, away from it. So anyway, that kind of wraps up the internal mods to this thing that I did to mainly address the thermal issues that I thought existed or looked like they existed to me. And then I'm going to put both of these on the audio analyzer suite, with one of them having this change and the other one left like it was, with a 47K resistor and a 1 UF cap, and see if there's any difference in the performance. I think that'll be an interesting thing to see. So that'll probably be in the next video. So anyway, this is like a place to wrap up this video. So I hope my thought process on how to provide some ventilation for this amp makes sense to you. And like, got vents in the bottom. We got this little screen here in the top. Didn't want to put too much on the top, so it didn't distract from the clean appearance. You could put another screen like over here, but I think this one here is going to be enough to let the trapped heat come out of the amp and get kind of a cross ventilation across the amplifier. So let me know in the comments what you think. You think this is enough? It's obviously going to be better than what was there. And do you do this kind of stuff when you're building an amplifier, or you just seal them up and hope that the components are heavy duty enough to handle the heat that they build up when they're running? I think that's a bad idea. And I think it's why we see so many tube amps with cooked capacitors and that need to be recapped, and that have cathode resistors frying, and all the stuff that we see on this channel and in the forums happen in a tube gear is from lack of thermal design. So if you enjoyed this video, please subscribe, please like the channel. Thanks to all you Patreon folks. Again, thanks to all you viewers out there, and until the next video, have a nice day.